Good morning everyone. Today I will be presenting on basic statistics formula focusing on test series, R values and related statistical tools that help you analyze and interpret the data effectively. Introduction to basic statistics. Statistics is the science of collecting, analyzing and interpreting data. It's used in research, business, medicine and many other fields to make data-driven decisions. There are two main types, descriptive and inferential statistics. Descriptive summarize data while inferential help us draw conclusion about population based on samples. Statistics help Statistics helps analyze and interpret data used in science, research, business, and more. Two main types. Now, types of statistics. In descriptive statistics, we simply describe the data using measures like mean, median, mode, range, variance, and standard deviation. To summarize what the data shows, inferential statistics, on the other hand, allows us to make conclusion or prediction about a population based on a sample. It includes techniques like T-test, correlation, regression, and ANOVA. So descriptive tells us what is happening, inferential tells us it might be happening or what will next. Mean, median, mode formulas. The mean is the arithmetic average. We find it by adding all data values and dividing by the number of observations. Median is the middle value and data is arranged in order. Mode is the most frequently occurring value. For example, if our data is 2, 3, 3, 5, 7, mean equal to total sum 20 divided by number of observations equal to 5 equal to 4, median equal to 3, mode equal to 3. These three measures give us different ways to understand the center of our data. Variance and standard deviation. Variance and standard deviation tells us how much our data is spread out from the mean. If data points are closer to the mean, we have low variance. If they are far apart, we have high variance. The formulas are pi square equal to summation of x minus mu whole square divided by n. Standard deviation pi equal to square root of variance. For instance, test score like 80, 81, 82, 83, 84 have a low standard deviation, meaning most students scored similarly, but score like 50, 60, 80, 90, 100 have a higher standard deviation, meaning performance varied a lot. Introduction to hypothesis testing. Hypothesis testing is a decision-making process. We start with two hypotheses. Null hypothesis H0, assume no effect or no difference. Alternative hypothesis H1, assume there is an effect or difference. We collect data, calculate a test statistics, and then compare it to a threshold to decide whether to reject or accept the null hypothesis. This is the foundation of scientific research. Introduction to t-test. The t-test is a statistical test used to compare the means of two groups. It tells us whether the difference between the means is real or just due to random chance. There are three types of t-test. One sample t-test compares a sample mean to a non-population mean. Independent two sample t-test compares the value of two different groups. Paired sample t-test compare means from the same group at two different times before and after. T-test formula and example. The formula of a independent t-test is t equal to x1 bar minus x2 bar divided by square root of s1 square divided by s1 n1 plus s2 square divided by n2. Here x bar is equal to sample mean, s square equal to variance, and n equal to sample size. Let's take an example. Group A mean equal to 85, s equal to 5, n equal to 10. Group B mean equal to 80, s equal to 6, and n equal to 10. So t equal to 85 minus 80 divided by square root of 25 divided by 10 plus 36 divided by 10 equal to 5 divided by square root of 6.1, that is 2.02. We then compare this t value with a critical t values from statistical tables based on degree of freedom. This is the solution of the given example. T-test interpretation. If the calculated t value is greater than the table or critical t value, we reject H0 and conclude that there is a significant difference between the groups. If the calculated t value is smaller, we fail to reject H0, meaning there's no significant difference. This helps us confirm whether an observed change or difference is statistically valid. Correlation RValue. Correlation measures the strength and direction of a linear relationship between two variables. The correlation coefficient is represented by R. In it ranges from +1 to -1 to +1. R equal to +1 perfect positive correlation. R equal to -1 perfect negative correlation. R equal to 0 no correlation. For example, if height and weight have R equal to 0.894, it shows a strong positive correlation. As height increases, weight tends to increase too. Numerical example of for R value. For example, using data x equal to 1, 2, 3, 4, 5 and y equal to 2, 4, 5, 4, 5. We calculated R equal to 0.894. This means around 89% of the relation between x and y is positive correctly. Rest is strong positive correlation. Coefficient of determination. R square or the coefficient of determination is simply the square of the correlation coefficient. If R equal to 0.894, then R square equal to 0.799 or 79.9%. This means about 79.9% of the variation in Y can be explained by X. Regression analysis. Regression analysis helps us predict one variable based on another. The regression line equation is y equal to a plus bx, where a is the intercept and b is the slope. For example, If we have x bar equal to 3, y bar equal to 4, the sx equal to 1.5, sy equal to 2, and r equal to 0.8. Then b equal to 0.8 into 2 divided by 1.5, that is 1.07, equal to 4 minus 1.07 into 3, that is 0.79. So the regression equation is y equal to 0.79 plus 1.07x. ANOVA, analysis of variation. ANOVA is used to compare the means of three or more groups. The formula involves the F statistics F equal to between minus group variance divided by within minus group variance. If the F value is larger, it indicates that at least one group mean is significantly different from the other. ANOVA is very useful in experiments. Comparing multiple samples, for example, comparing test score among three teaching methods. P-value concepts. The p-value tells us how probable our results are if the null hypothesis was true. If p is less than 0.05, then it means the results are statistically significant. We can reject the null hypothesis. If p is greater than 0.05, the results are not significant. If we fail to reject H0. P-values help us measure the strength of our result. Conclusion. T-test compares means and tells if two groups are different. R-value shows the strength of the relationship between two variables. Regression. Predict outcomes using relationships. ANOVA. Compare multiple group means. All these techniques help us understand and interpret data significantly, supporting decision making in research, education, and business. Thank you for listening. I'll be helping you to take any question.